Silakan, Prof. Masih mute ya?
Saya buka Pak Rio ya.
Ya, silakan.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. Thank you very much for coming in our webinar today. We have a special distinguished presenter today. And before I introduce our speaker today, maybe first the speech from General Secretary of the BKSTM, Professor Aryo. And so please, Prof. Aryo, to give us opening speech for this webinar.
Okay, thank you, Prof. Nasruddin. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Thank you very much for your coming in this webinar session from Badan Kerja sama Teknik Mesin, BKS-TM. I would like to express my gratitude to Professor Chef Ferguson. This is our colleague from Auburn University from US, and now we have a special talk about the research and publications, and maybe a little bit short introduction for Professor Jeffrey Fergus. He is a professor and associate dean for undergraduate studies and program assessment in Auburn University. So thank you very much for your time and for your sharing to us. BKSTM is Indonesian mechanical engineering higher education's Indonesian Consortium for Mechanical Engineering study program. So we have 146 member of university that has mechanical engineering study program, and maybe later in this next year we have more and more member of the mechanical engineering. So we have activities such as development of a curriculum and lecture materials and supporting for teaching to mechanical engineering study program. And we have also a division for research and development, and this is now held by Professor Nasruddin. So today we will have a very nice sharing from Professor Jeff Ferguson. So I would like to thanks to Prof. Jeff Fergus for your time to talk with us. Now the participant is from Indonesia, so from Sabang to Merauke. And thank you very much for your time, and also Professor Nasruddin, thank you for your time to become moderator. So I hope we have a nice and fruitful discussion today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Aryo, for introduction about BKSTM. And now I will introduce our distinguished presenter today. I received your CV, Jeff, but it's about 30 pages. So I will just mention the lots of information, but I will introduce you only for some maybe the most important point for us. Okay, our presenter today is Professor Jeffrey W. Fergus, PhD, PE, Fellow ECS, Fellow ABET. He's Associate Dean for Undergraduate Studies and Program Assessment. He's a Professor of Material Engineering at Auburn University. He has received Material Science and Engineering PhD from University of Philadelphia, US, and then Bachelor of Science in Metallurgical Engineering with honors from University of Illinois. He is now as Associate Dean for Undergraduate Studies and Program Assessment, Samuel Ginn College of Engineering, Auburn University. Before, he is also Associate Dean for Program Assessment and Graduate Studies, Samuel Ginn College of Engineering, Auburn University. Now, he's also as Academic Leadership and Associate Dean for Undergraduate Studies, and then Program Assessment from 2014 till now, and is also one of the ABET member. He's a chair of Accreditation Council Training Committee from 2022 till now, and is also lead facilitator for Program Evaluator Training till now, chair of the Engineering Accreditation Commission, and ABET fellow. We invited Professor Fergus today for the topic about research. So as we see from his CV, he published many articles, and most of them is in reputed articles in reputed journal. So that's why we invite him to share about his experience on doing research and publication. So thank you very much, Jeff, for your coming today. And then I think it's very important for us, especially for BKS-TM, because now we need to increase our research and publication in all of our mechanical engineering. Professor Jeffrey Fergus, time is yours. You have 40 minutes for presentation and 10 minutes for discussion. Yes, please.
Okay, well, thank you for that kind introduction. I probably won't use the 40 minutes. I'd like to have more discussion. Okay. So I have probably a little bit shorter presentation, and I hope there's questions so I can answer what you're interested in.
Okay.
So I'm going to pull up some slides. Okay, can you see my slides?
Yes, we can see.
Okay, very good. So there's really three things that I was going to talk about, just a few slides on each. The first is just my background, just to show where I, as a student, particularly before I started as a faculty member, the way I got into research and the experience there. Then I'll have a few tips on graduate studies in general, as well as writing publications. And then at the end, I just have a little bit of information on the university system in the US, in case anyone's interested in doing research in the US or collaborating with researchers in the US, just so you know the types of different institutions that we have, to know where those opportunities might be. Okay, so the first, again, is my background, which you heard some of that already. So this is basically the research experience I had before starting as a faculty member. So the first is listed there as University of Illinois. That's where I had my undergraduate degree. I've listed there teaching assistant. So that wasn't actually research. I mentioned it only because it was relevant in terms of my moving into the faculty type role. So my first research experience was actually at Argonne National Lab as an undergraduate researcher between my third and fourth years. And that I worked on corrosion of aluminum interconnect or current collector materials in the sodium sulfur battery. And prior to that, I really had no interest in going to graduate school. But it was after doing that research as an undergraduate that I thought this is something I might like to do. And so I asked around how would I pursue this career? And that's the reason I went on to graduate school. So in general, I'm a strong proponent of undergraduate research because we want all students or as many students as possible to try it to see if it's what they like. If it is, then they can pursue graduate studies. If not, then that's fine. They can go off and do something else. So that was my first research experience. Then I went to graduate school at the University of Pennsylvania in Philadelphia. And there I worked on ceramic coatings, particularly silicon carbide and silicon nitride, for gas turbine engine materials, particularly carbon composites, to be able to elevate the operating temperature. Carbon composites go to very high temperatures, but they will oxidize very quickly. So you need to coat them with a protective material. So that was my second experience in research. And then after that, I went on to do a postdoc experience at the University of Notre Dame, which is in South Bend, Indiana, not too far from Chicago, kind of in the middle of the US, middle and the north of US. And there I worked on oxygen sensors for use in molten steel. So in molten steel, you need to control the oxygen content to control the properties. And so they have probes that they'll put into the steel while it's molten so that they know what additives to put in to control that. So this is kind of where I started. And as I put this together, I looked at what I've been doing recently, and although between then and now I did a lot of different things, a lot of different projects, as a researcher, you essentially have to follow where the money is and where you can get support to do research. That's where you do research. And so your interests will change over the years, and they did. And so after that, my role was as advisor to students, PhD students and master's students, and some postdoctoral work as well. And then, as you heard, I was also involved with graduate studies from the Dean's office, the Associate Dean for Graduate Studies as well. So I had some different types of experience related to graduate students. But then I look back at after putting this list together, at what I've done recently, and these are my last 3 projects. And what I found interesting here, the first is a chromium sensor for use in solid oxide fuel cells. This is related to something called poisoning of the interconnects. The second is CMAS corrosion, and CMAS is essentially dirt. It's calcium, magnesium, aluminum oxide, and that can get ingested into the turbine engine, and it deposits on the thermal barrier coatings, which are put on the turbine blades to be able to operate or increase the operating temperature, and they enhance the corrosion of those blades. And then the last was on solid electrolytes for lithium-ion batteries. That can improve the safety and have different configurations, smaller configurations, higher operating temperature, things like that. What I found interesting here is that all these were very similar to those first 3 projects. So sometimes your career may wander around for a while, but sometimes it comes back. And so I'm working on batteries at the beginning and batteries at the end, and corrosion at the beginning, corrosion at the end, and coatings at the beginning and coatings at the end. So that was interesting to me. So that's just a general background, just gives you a sense of the type of research I did, kind of where I started. And as I say, in the middle, there's a lot of different projects with a lot of different collaborators. So what I wanted to do next is just go through some tips for graduate studies as you go through your studies and prepare to or do research and prepare to do more research. So a few things here. One is persistence is very important, not just in research, but in anything, but in research in particular, because research, by the nature of being research, you're doing something nobody else has done before. If not, it's not really research. And so if no one's done it before, it might not work. And that's kind of part of the business, is that things don't work and you have to move on. You have to learn from what happened, whether it's a mistake. I mean, as a student, you are learning, and we all make mistakes, even those that are more experienced, but when you're starting off, you may tend to make more mistakes, but that's part of the learning process. And I said here, don't get discouraged by failures, and I put the failures in quote because failures aren't necessarily failures. It's finding something that didn't work, and that's actually a learning opportunity. So don't look at it as failing. It's this didn't work, and if you can understand why it didn't work, then you know how to do it differently, or you know that that idea you have may not work. The ideas we have, if we knew they would work, then it's, again, not really research, it's just production. It's not research. Research is trying something that's new, testing on an idea that no one's, we don't know if what the answer is. We need to confirm that our hypothesis is correct or not. So that's one main point, is that you really have to find a way to get through those failures, which you will have, and not let them discourage you. We all have them, and we learn from them and move on. Okay, the second point I wanted to make is that it's very important to build connections. As you go through your career, you're going to work with a lot of different people. Projects are typically involve a lot of teams of people with different expertise and different backgrounds. And so it's important to have a good network of people. And so the students that you're working with now, either working on the same project or they're just also in the same program, those students may later, you may go off and do something different initially, but eventually you might come back and be colleagues again, or you might encounter them again in some conferences or for some collaborative opportunities. So it's very important to build those networks of people. So along those lines, you want to try to expand that network, take advantage of going to meetings and conferences when you have the opportunity to do that. Meet a lot of people so that those people can be your collaborators in the future. You can learn from what they're doing and work with them possibly in the future. I think professional societies are very important, and this is an example of that. An opportunity for students from different mechanical engineering programs throughout the country to engage with each other, and that's going to help to expand your network. And so there's professional organizations, depending on what area you go into. There may be different organizations that you can get involved in. It's important to do that, to you're really serving the profession, because there's a lot of support that those societies provide, and they rely on volunteers working in those societies, and it's important to make those contributions. And along those lines, when you're doing things like that, and this is not just for the volunteer, but anything, sometimes people will take a small task, and maybe it's not a big role, and not take it seriously and not try to do as good a job as you can. And I think it's important to, even for a small task that may not be a big deal, to do the best you can. And what happens when you do that is, over time, people know they can count on you. And then they'll start to give you more important things to do. And that will create opportunities for you. So it's important that even if something looks like it's a small task that maybe is not that important, still take it seriously and do a good job. And it'll pay off, and that people will know and respect that they can count on you to do something that's more important. The last point I have here is to be open to all different kinds of opportunities. Different kinds of experiences can really help you expand the range of things you can do, your experiences, the people you work with. So when you have opportunities to present to different groups of people, particularly different types of people, different types of presentations, one of the things important in communication is understanding your audience and being able to communicate both to colleagues, but also to people who aren't experts, to be able to explain what you're doing to people who may not have the same technical background. It's important to take opportunities to do that and look for opportunities for collaborations and different types of experiences. Proposal writing is important. As I mentioned before, your research will depend on what you can get funded for, whether it's through the organization you're working for or going out to get to propose to get money for from somebody else to do the work. That's important to understand how to do that and to do that effectively. So those are a few things that I share just to think about as you're pursuing your graduate studies. So I hope that's helpful. I also wanted to talk a little bit about kind of the skills that you need to be successful. And I've divided them into two groups, and one are the ones that you probably think more about when you're thinking of mechanical engineering. You know, the knowledge of the field, the understanding of the concepts, that you can do different types of experimental techniques. That's often a way to contribute to a group. If you have the expertise to do a certain type of experiment or certain type of analysis, you can add a lot to a team. That you can do analysis, that you have ideas for creative ways to do things. That's probably what you think of when you think of engineering. But to be successful, there are also non-technical skills. Sometimes people refer to these as soft skills, but basically they're not necessarily related to the details of the engineering. Communication is very important. As I mentioned before, in written and oral as well. You have to be able to communicate what you've done, what you'd like to do to different people and do that clearly. And that's an important skill to have. Teamwork is important. Most real projects are done by groups of people. So you need to be able to work on teams of different types of people to be effective. You need to develop leadership skills. As you move up in your career, you'll be leading teams, and you need to know how to be able to motivate and coordinate teams. And all of these are kind of generally interpersonal skills. How do you work with other people? How do you interact with other people? That's important to be able to do so that you can progress and be successful. And the last item there is cultural competence, which this is really all of those same things, but in the context of working with people who are different from you, different backgrounds, and being able to understand how to adjust as needed when people have a different background than you might have. So these are just some skills that are useful to be successful in general, not just in engineering, but in general. On the right, I have, this is something I learned from a colleague who works in our career development and corporate relations office. And this is a strategy that's used when preparing for interviews. So when you're looking for a job and you might need to have an interview to convince somebody that you're the right person for that job. This is a way to prepare for that. And I put it here in context of these skills, because often when an interviewer is trying to find out is, do you have these skills? And they're asking questions to see, can you work on a team? Do you have experience with leadership? And they want evidence of that. And this STAR interview response strategy is a way to do that. And the reason I mention it now is it's important to think of examples of when you exhibit these skills. For example, in leadership, that could be in maybe in an organization, in a student chapter of this organization, that you become a leader in that group, and that's a leadership position. And there's certain skills, certain things you have to do that could be translated into a employer-related leadership position. So this strategy is a way to prepare for that. And this is when an interviewer might ask you, when have you worked on a team and and when he'll work on a team and having an effective outcome or something like that. And a response to that is a good response to that follows this strategy, and that is, first you describe what the situation was, what was it that you needed to do, or in this case, what the team needed to do, what actions were taken, and what was the result, and what did you learn from it. And if you have examples of that already prepared, so as you're going through your studies and you think about where you're demonstrating these skills, and have some examples in the back of your mind, so if someone asks you that, you're prepared to give an example of when you worked well on a team, or when you demonstrated leadership, or when you had a group that had people from different areas, so you really had to manage that through cultural competence. So this is just something to think about as you're trying to develop these skills, and think of examples that you can have, specific examples. It's important that the example is specific. It makes it more real to the interviewer. Okay. Any questions on that before I move on?
Is there any question? Maybe later. Yeah.
Okay, we'll do it later then. So the last thing I want to talk about in terms of the skills is writing. And of course, writing is an important part of research. You have to document your work, and you do that in whether it's a dissertation or a journal publication or a conference paper. And one of the things that I think is very important when you're writing is that really the organization is critical. And the way I write myself, and the way I try to tell my students to write, is not to start writing things out in sentences at the beginning. Sometimes people, when they're writing, they'll say, oh, I want to write X pages today, and then X pages tomorrow, or whatever it might be. I find it's more effective if you get everything organized and in place before you start writing. So what I do actually is I use a spreadsheet to do this, but really start with an outline of what your paper will be, for example, and just keep adding details to the outline, not putting it in sentence necessarily, just brief phrases so you know what the point was. And the reason that I resist writing the sentences is, in those phrases you can move things around very easily. But once you write it in text, it becomes more difficult to move things around. You have to rewrite the text. So it's better if you get it organized before you even start to write sentences. So what I'll do is just have that outline, and if I need to change the order in the outline, I just move things around. Also, prepare all the figures and tables before you write. Because sometimes what you find is you write something that you think the figure shows, and then when you actually put the figure together, you realize it doesn't show exactly what you thought it did. So it's important to have that figure just as you're going to present it, to make sure what it's going to look like, what it shows or what it doesn't show, before you write those sentences. As I said, for me, this is more effective. In the end, I think it's actually faster, but it takes a long time before you start to get text. I do this particularly when I've written review articles, and I probably do 90–95% of the work before I actually write the first sentence, typically, because it's all gathering the information, organizing the thoughts, organizing the logic, that why this part is presented before another part, how this leads into that, getting all that in order. And then once you write it, it writes much more smoothly. It's easier, and it will be easier to read as well. It's hard to do this because you feel like you're not making progress. You feel like, oh, all I have is an outline and I don't have any words written. but from a lot of experience writing papers, I'm convinced this is a more effective way to write than to just start writing sentences and try to fix it later. It's very difficult once it gets into sentences and pulling out the parts that you want to move. You have to rewrite the sentences. So that's one point I think is important for writing. Excuse me. The second point is be sure to use the scientific literature. It's important to demonstrate you know what's going on in the field. It also, you can use that as part of your argument. You have some results, but really to make the point you want to make, you may have to use other people's work. So you can combine your work with other people's work and make a more complete picture to support whatever it is you're trying to say. So really think of all of the work that's been done you can use. You just have to cite it properly, give it proper credit, but you can have a figure that has some of your data on it and some data from the literature, and you just label it differently and give the credit where credit is due, and you can make points using all of that information. So it's really important to be aware of the literature, to do proper research, to make sure that you do that. So those are the two kind of main points I wanted to make about writing. So the last thing I'll talk about, and this is just again for information in case you ever want to find an opportunity at a U.S. institution or collaboration with U.S. institution, just so you know the different types of colleges that are at in the U.S. to know what their emphases are. So there's a system called the Carnegie Classification that's used in the U.S. And so there's three groups of what are called doctoral universities. That means they offer PhDs. And they're basically divided by the research activity. So there's what we typically call R1s. Those are very high research activity. So those are the highest level. And that's based on numbers of PhD students, research dollars per faculty member, things like that. And then the R2s have a little bit less research, and the doctoral have less. So this is just a measure of what's the level of research activity at that institution. Then there are others, master's and baccalaureate, associate's degree. Associate's degree are 2-year degrees. Some that's focused on special things, special topics, and then tribal colleges is for the Native American groups in parts of the country in the U.S. So that's one way institutions in the U.S. are classified. So if you're looking for research opportunities, you're probably going to be looking at the R1s or maybe the R2s is most likely where you'll have more opportunities for research with U.S. institutions. Now, in terms of those research universities, here I've added a couple different categories. So you have the R1s and the R2s in the middle there. You have Ivy League, or that class, I would put MIT, even though it's not an Ivy League, but in that class of very, very competitive institutions. Then you have the R1s. Those are the ones that you're probably familiar with. I've listed a few here. Berkeley, Georgia Tech, Illinois, Michigan, and Duke. I've put my own institution there. We are R1. The R2s, you may not have heard as many of those, but they're just a little bit less research activity, but there is research activity, so there are opportunities there. And then there's small liberal arts colleges, and these are a little bit different in that they're undergraduate only, but the faculty members are still expected to do research. So they do that research themselves as well as with undergraduate students. These are smaller, so they're working with a small group of students. So their research, a lot of research going on, just a little bit, the magnitude is not quite the same, and the nature is different. In the US, most of the research is done by graduate students as opposed to undergraduate students. But this is an exception. So some of these you may or may not have heard of. They're, again, relatively small, but they provide an undergraduate experience. And so just the last slide here is just a different way of classifying. So there is a group of institutions called land-grant institutions. These were established by the Land-Grant Act in the 1860s. And these were established prior to that. Most of the institutions were focused on kind of classical studies, things like history or literature, those kinds of studies. And they were only available to wealthy people. So the idea with the land grant, there was kind of two parts of it. One is to really provide opportunities for residents of the state. So in the US, the states, a lot of the education is controlled by the states as opposed to the federal government. And so each state got one land grant institution. So they had some land that they could use to have a university. And the focus of those was to be on more practical areas of study. So that was typically agriculture and engineering. Finding better ways to feed more people, finding better ways to support the industrial development that was starting at that time. So I've listed here a few of those, and I listed Texas A&M. The A&M is actually agriculture and mechanical. So that's where the those two areas of agriculture and engineering came from. At that time, mechanical arts was the name that was used for engineering. NC State, UC Davis is the land grant as opposed to Berkeley in California. Iowa State, Auburn is also the land grant in Alabama. Then there was a second round of land grants in 1890, and this was in the 1860s, of course, was when the U.S. had the Civil War, which ended slavery. So even after that, even though there was no slavery, there was still the African-American students didn't really have access to education. So these institutions were established to provide access to African-Americans. So Tuskegee is one of those. That's actually very close to Auburn. North Carolina A&T, Alabama A&M are some examples. Those are also what are called historically Black colleges, university, which again are focused on Black students, and similar for Hispanic. So these are institutions that support the minority groups in the U.S. There's also military academies. The West Point is for the U.S. Military Academy, Naval Academy, Air Force. And then there are also some religious colleges. Most of those are small, though there are a couple big ones like Brigham Young and Liberty are fairly large. So that's what I wanted to share. And so I'm happy to answer any questions. I guess I took more time than I thought I was going to, but I'm still happy to answer some questions.
Okay. Thank you very much, Jeff, for a nice presentation. Bapak Ibu, apakah ada yang ingin ditanyakan atau didiskusikan? Please, if you have any question. So,
yes,
Jeff.
Yes, Prof. I have a question.
Yes, please.
Yeah. Regarding your project, you have the three projects, is this right? And I look at the second project, like the CMAS corrosion of the thermal bonding coating. Now I'm going to ask you about what kind of the method you use to do the research for this CMAS corrosion. I mean, we have the specimen, we make the specimen, and then to do the experiment, or we use the existing object, on the, like, for example, like the turbine blade, and then we cut the turbine blade, and then to do the research. What kind of the method you do for this research, your research?
So we were looking at using new materials for the thermal barrier coating. So the material that's used now is zirconium oxide, most commonly used. And so we were working with a company that had an idea for a new material. While they were developing the actual coating, we were just making ceramic materials of that coating material. So they weren't actually coatings. They were the potential coating materials. And then we were looking at the corrosion of those ceramic pieces. So I think you're getting to a good point that eventually then you have to actually make it as a coating, which might be a little bit different. Microstructure will be different and the behavior might be different. And then on a turbine blade, which also might be different. So this was really the first step to look at what coating compositions might have better resistance to corrosion by the sea mass. So we would have make a piece of ceramic, we would put some the sea mass on that and then expose it to certain temperatures and then cross-section it, look at the microstructure and see the extent of the reaction. Does that answer your question?
And if we have the existing object like the blade, and what can we do for this object? I mean the turbine blade. If you use the new material, it's okay, no problem. But if you want to investigate the existing blade, what can we do? We cut the blade and then to anything. What do you think, Prof?
You could do that. Of course, that's very, very, very expensive. Those blades are really expensive. So I think you try to minimize doing that as much as possible. So to do other types of tests before you work your way to that. But eventually, if you did have an actual turbine blade that you wanted to see the extent of the corrosion, you might be able to get some idea from the surface, but if you really wanted to characterize it in detail, then you could section the whole sample. But then that would destroy that turbine blade, and those are thousands of dollars,
yes,
tens of thousands of dollars. So it's very expensive.
Okay, thank you very much.
Okay, thank you very much. Another question? Okay, before next question, maybe I have a question for you, Jeff. As you know, we as a developing countries cannot compete with developed countries for doing research. So, in your opinion, which area should developing countries focus on their research?
I think finding where you have something to offer to the project. And it may be you may need things from a more developed country, certain equipment, but there may be something that you have that you can offer that will contribute to the project. We had a project where we took advantage of the Badan, the neutron diffraction facilities here. So we were able to have a collaboration, because even though we do have that in the US, but it's not common. I mean, there are only several in the US. So that was a way to make an argument to the National Science Foundation that, well, there's a facility here we can use that will help us to complete the project. So if you can find some, I mean, it may be not always equipment, but some expertise, particularly if there's maybe something in that's related to natural resources that could lead to, you know, if it's sustainability related, renewable products where there's a real contribution, something that you have and a developing country doesn't have, that would be a particularly strong area where you can find, or maybe some place where something needs to be tested in conditions or in situations that are here but aren't in the other country. Those would be the strongest way if you have something to add, particularly if the other group doesn't have. Other cases there may be where you're not the only one, but you at least can contribute and contribute to the project. Because there's advantages, even if they could do it within their own country, there are advantages to, you know, engaging on both sides outside in terms of the experience for the students. So I think you can make that argument as well, that if it helps the students involved to be engaged outside of their own country, that helps their development, their cultural competence development. So I think those are the things to look for, where there's natural resources, where there's that opportunity for personal development because of the the cultural change, the cultural differences. That's probably the way you could leverage your contribution.
Okay, the next is about based on your experience. Sometimes we have difficulties to describe about novelties in our research. In your opinion, what exactly novelties for our research?
I think that's where it's important to know the literature, because if you don't know the literature very well, then you really can't explain what's new. Or if you do, you may not be correct. You may say this is new, but then actually there was paper on it that you weren't aware of. So I think that's probably the most important thing, is really understanding what's out there. And if you really understand what's out there, then you can see, well, what is it that we're doing that isn't there? Whether it's a different process that you're using that nobody else is using, or a different initial material, or you saw something that nobody else saw. So I think the first step is really understanding the baseline to know how you are different from that in whatever way it is.
Okay, Bapak Ibu, do you have any question?
Yes, I have a question. Can I ask?
Yes, please.
Thank you, Professor. I have difficulties in funding of my article, to publish my article, since I've already searched in the Scopus indexes publisher. They mostly have a very expensive author processing charge. Can you please suggest me how to overcome this? Because I have we need to fund for the article. Thank you.
Yeah, I don't have the detail. I don't know all the different journals and all the different costs. But I know there are some journals that do not charge. Now, there are some that charge for open access, and others that, if it's not open access, they won't charge. I don't, off the top of my head, know the different rates in the different journals. Of the ones that, of course, it depends on your area what those journals are. And I'm, for example, the journals I use, Journal Electrochemical Society, for example, doesn't charge. They'll charge for open access, but not for if it's not open access. So, but I'm not as familiar with the mechanical engineering journals to know which of those do charge or don't charge. But sometimes it might be that if it has to be open access, then that makes that limits it, because open access usually charges. Some are not as expensive than others, but they do often charge quite high rates.
Yes,
I'm
correct.
sorry, I don't know much about the mechanical engineering journals to be able to answer that.
I think there are many journals with no APC, but maybe the quality, and we have to have a good quality of journal. Sometimes also, challenging for us to submit there. So this is correct. You can submit your journal with no APC. There's many journals in mechanical engineering area without this APC. Okay, next question.
Excuse me, Prof.
Yes, please, Mr. Gama.
I am Hakam, Prof.
Oh, Hakam. Oh, okay, Mr. Hakam. Okay. How are you?
Thank you. Fine.
Yes,
I will
please.
about the patent and when we have to publish in patent and when we have to publish in article, and how we can decide about this output of research. Thank you.
Yes, please, Jeff. So the question is about if you have research, what is the output? How to choose as a patent or as a publication?
Well, it really depends on the nature of what it is and what you plan to do with it. If it's something where you can have a chance of licensing, then it might be more valuable to have the patent than a publication. If it's not likely to be licensed, then maybe the publication is more important. And of course, you can have the publication later. May not be as impactful, but you could still get a publication based on some of the work as well. But it really depends on what it is and what you might be able to do with it.
Yes, okay. Okay, Mr. Hakam, is the answer?
Okay, thank you, Prof.
Okay, okay. Next question. So, Jeff, in your experience, how did you start your research? I mean, is when you start your research, is there your money is there, your equipment is there, your proposal is already accepted, and then you just doing research, or you started from zero for your research first?
So when I started as a student or as a faculty member, or which I guess maybe for since this for students, I can start as a student. But when I started, it was a new project. So I essentially had the proposal that the professor had written, and that's what I started with. And so there was a postdoc who was working on a similar project. So there were two projects related to both looking at high temperature materials for turbine engines, and just two different materials. And so I had that postdoc to help as well. That we were, although he was also starting a new project, so we were both kind of starting, but he had more experience from his PhD where I came straight from my bachelor's degree. So in the US, at least depending on the discipline, but I think it's becoming more common, you can go straight from your bachelor's to a PhD. And so I was straight from my bachelor's degree starting research. And so there's the proposal and reading papers of how they do things and talking to my advisor, talking to the postdoc and building the apparatus and going through the procedure and not doing everything the best way the first time, but learning over the years. And that's, and in a way there was times when it felt like things were going more slowly when I looked at other groups where there might be, for example, there was a group that was working on beta alumina electrolytes in the same floor. And they basically had a machine. I mean, they just would change to a new dopant and they had this process. And so someone could come in and very quickly starting to get samples and get results and get publications. Whereas I was spending time calibrating a furnace and doing these things and felt like it was slow. So at first it was kind of frustrating, but then in the end, I learned a lot doing that. So then when I went for my postdoc, or then when I went for a faculty position, I knew how to get started. I didn't expect that someone's going to already have everything set up and I just, do things a little bit, a different set of materials or something slightly different and go through that system. So it's really a learning process, but I think there is some advantage to having to go through that. It might be painful at the time, but whether you're doing that as a student and when you start a job and they expect you to, even if it's in a company, say, and they said you, okay, here's your lab, here's your room, here's your room, you're going to buy equipment and set up a lab to do X, and you've never done that before, you're going to be stuck. Whereas if you've done it before, you say, okay, I know, I have to order this, order that, put this together, and you can figure it out much more easily. So there's good and bad. If you get results quickly, you get more papers, and that's good. But you may have trouble later starting. Or on the other hand, takes a while to get papers, but maybe you're better prepared for putting up the next time.
So it means failure is very important for learning curve.
Failure, you know, I think we put such a negative connotation on that, but really failures are, you can learn a lot from a failure, much more than a success sometimes. So you just have to look at it, and that's just part of, if you're really doing the important things, new things, it's not going to work every time. And you know, all you've done is, and that's I think that was a maybe it's Thomas Edison said, you know, he didn't fail, he just found a way that didn't work. And you go to and find another way, and maybe you have to go through 10 or 20 ways that don't work, and you find the one that does.
That's correct. So creativity is also important, because sometimes we just say that we don't have any equipment, we don't have money, but I think some researcher I know, they have a creativity. Based on this creativity, they can publish some journal in some journals, and this is more important, I think, than the equipment that you say. Based on your experience, how big is your success rate for your proposal, research proposal, and your article submission in your experience till now? Success rate.
I don't have numbers, but I can tell you that the proposal rate is much lower than the article. The article is higher, not 100%, but
good.
But usually articles, you kind of shoot for a good journal, the kind of the best journal you think you can get it into, and if it doesn't, just rewrite it and go to another journal. And usually you can get it published eventually. But proposals, well, two things. One is it's much harder, so there's much lower success rate in general. But also you do have a second chance, but it's a much longer time frame. But an article, first you have a chance to respond. So the review comes back and you have a chance to respond, and you might be able to get it through. And even if you don't, you can immediately send it to another journal. Whereas a proposal, you get it back and they didn't accept it. That's it, right? And you have to wait till the next round, which might be a year or maybe more before you can resubmit. Or you could find another, unless there's another opening, another solicitation that happens to fit. So I don't know the numbers, but the proposal's low and the article's higher, much higher.
Okay, Bapak Ibu, is there any question? I think it's very interesting for us to know what exactly in our research till now. Because Jeff, in my opinion, also collaboration with I can say famous authors is also important for us, I think, because we can first learn from them how to do research, and then how I think I don't know, I think some reviewer also look at who is writing this article. Actually, it's so important. What's his opinion?
Yeah, I mean, I would say any collaboration, even not just with famous authors. I mean, other collaboration's good when you get different perspectives and people have different expertise in general. Of course, if you have someone, the name can sometimes help you. It shouldn't be that way. I mean, the work should be evaluated based on the work, but you're right, it's people. People have those biases in their mind based on other experiences, and we don't typically use double-blind reviews. We in scientific, at least in my experience, it's usually the author doesn't know the author doesn't know the reviewer, but the reviewer knows the author. To do it properly, you have double-blind where neither knows each other. For example, in the ASEE, the American Society for Engineering Education, those reviews are double-blind. So when you submit the paper, any evidence of that could identify who it is. So if you're doing some study in your university, you take away your university's name, you take away anything that would identify where it is. So when the reviewer is looking at it, they don't know who wrote it. So then that removes that bias, positive or negative, right? It can go either way. That it's just looking at the work, and is the work valuable or not, and then that way you can get rid of that. We don't do that in science and engineering, at least not in the fields I've been in.
Okay.
But you're right. It's there. It's not. It's really not right. But there's not. I mean, it's there. You can't avoid it. It shouldn't be, but it is.
Okay. Next question. We have
Prof.
okay. Mr. Hakam, please.
How can we get a research sponsor in overseas, for example, from Prof chef country, for example? So can you can explain to me or clue how we can get a good proposal? Maybe like that. Thank you.
So that was research sponsor from the U.S.
I think so, from US, I think.
Okay. I mean, the federal government grants typically, I mean, there are kind of organizations that support international work, and that's a separate, those are kind of outside the U.S. The federal grants, at least the ones I'm familiar with, they tend to they'll support a collaboration, but they kind of require both sides to have funding, and they provide the money to get people back and forth and host people, that kind of thing. Those are relatively, at least I haven't done one for a few years, but when I did, they weren't as competitive as regular research grants. They're typically not as much money, but what they do provide is and they do generally provide or require that both sides support it. So Indonesia would provide some money, and the US would, and it would support travel to go back and forth and hosting each country, assuming there's work being done in both places. So it's more about the collaboration. Those are the ones I'm more familiar with. For money going to another country, that's less common. I guess there's some, well, like this Fulbright is kind of some example of, although the money's not really going out, it's benefiting the other countries. So the ones I'm familiar with are more about establishing the collaboration. And they're not as competitive, but you do have to have research going on in both sides. That will help to, which then that collaboration can then help you to get more publications. And I know that's one of the things that you're trying to increase those international collaborations, which would be a benefit.
Okay. In US, is there any leveling for this grant? I mean, the how much the grant is there any, for example, for level ground, they have only small money and then increase. Is there any levelized in US for this result?
I'm not sure what you mean by leveling. A given program may have a limit as to, or a range that you can apply. They'll give some, the grants are going to be up to $1 million or up to 500,000 or between some value. When you say leveling, what do you mean? That
it's in money, number of money. How much big grant, small grant, for example?
Yeah, so each program will have some range that they're, sometimes it's a fixed, it's always going to be, it used to be NSF, the 3-year grants were 300,000. Now they're probably more like 500,000. Sometimes it'll be a range, but usually there'll be some limit that you can propose up to $1 million for this project. You could propose less, but up to 1 million, or sometimes it will give a range. But yeah, they'll usually have guidelines, and it will vary between program. So you'll, if it doesn't say, you might contact the program officer to say, what are you, they have a certain budget, right? So they have a budget and they're decided, they may have a range because they may want to fund some that are $1 million and others that are 500, and some combination of that, and add up to whatever their total is. But yeah, that'll usually be in the solicitation in terms of the ranges for that program. And they have some that are specifically, there's a NSF, National Science Foundation, has they call it eager, and it's a kind of faster turnaround and a smaller grant to help people to quickly do some work to get some preliminary results, or really not preliminary, but kind of the next level of results to prepare for a bigger proposal. So sometimes they'll have specifically small grants like that. So there is a range of different sized grants. The bigger ones will tend to be for teams, not for individuals. And more of the funding is going towards teams as opposed to individual investigators, which is why collaboration is so important.
What about from Auburn University? Is there any funding or grant from university?
Yeah, they have some, and I think most universities will have some what they call intramural grants. So it's the Office of the Vice President for Research will fund projects, and they'll have the same type of guidelines that you can propose up to X amount. There, what they're looking for is that you propose something where that's going to help you get those initial results so that you can get external money. They're not meant to just support faculty to do work. As part of the proposal, you have to explain, well, this is what we're going to do, and if we do this and are successful, we'll be competitive for this big proposal. It will bring more money to the institution. So yes, there's some of that. And the other thing is there's new faculty will always get what's called a startup package. So they'll get some amount of money to help them start their research. So buy equipment they need to do, fund a couple students maybe for a year or two. And the idea is that, because otherwise, if they have no money, all they can do is write proposals and they can't do anything until they get everything funded. That's going to take at least a year. Even if you write a proposal the first day, it's going to be a year before you have money.
Right.
So that's to help them both start without getting. Now the idea is they're still going to be writing proposals, but they're also can start doing some research, and that research will both give them some results so they can make more successful proposals. So that's university money that goes to new professors. At least at Auburn, there's not a lot of university funding for research. I mean, there's indirect in that part of your appointment is, part of your assignment is to do research. So that funding is, you're not teaching, right? It's state funds that are going to the faculty.
Lost connection. So
Wi-Fi maybe, Prof.
yes, sorry. I think it's bad connection here. So
in here or in US?
I don't know. I think how, Jeff?
In the US maybe. Oh.
No, Professor Jeffrey is in Depok, not in US. Oh, it's lost. Prof. Aryo, do you hear me? Oh, okay, it means Professor Jeffrey connection is.
Kontak dulu sebentar.
Please, Bapak Ibu, kalau ada
Bagus, ya.
pertanyaan mungkin bisa disampaikan dulu. Kalau nanti mungkin.
Ya, itu.
Halo Jeff.
Hello, sorry, I got disconnected.
Oh, sorry, no problem. It's okay. It's okay. It's normal. It's okay. Yes, please, can continue.
Now I lost my train of thought. I forgot what I was talking about.
It's about money grant in university, in your university.
Oh yeah, yeah. So most of you have to go external for either federal funds or some industrial funds, but most of it's federal. Some disciplines like the civil engineering will get a lot of state money from the State Department of Transportation, or yeah, that's one that's more of a state funding, but most research in engineering is from the federal government.
Oke. Silakan Bapak Ibu yang lain ingin bertanya. Any question? Prof. Aryo, maybe you will ask something for BKSTM research funding. Yeah. As Prof. Aryo said that we have around 147 members. Yeah, it's a big number actually, and yeah, actually we have the disparities is very high. Some study program have a good research funding, but some is a small study program. Yeah, sometimes also new study program. So I think it's also not easy to do research with very limited funding. So based on your experience again in US, how to improve the capability for especially for new or a small study program to increase the capability on research.
Yeah, we have disparities. There's ranges of capabilities in the U.S. too. They may be a different range shifted, but it's just, we do have differences. It is hard to get started, and it's really finding what capabilities you do have, what you can do, and be realistic, and find the collaborators or the places where you can maybe use some other equipment, or you know, for example, we have the national labs where you can work with the national lab, and part of their mission is to have, for example, Oak Ridge National Lab's not too far from where Auburn is, and part of their mandate is to provide user facilities. And so you can, now that there's they can only do so much, but they have those facilities, so you can figure out, what can I have this facility I can use, and what am I able to do with the resources I have, that I can go and do that and get some results that would be, you know, make a meaningful contribution. So it's really, I think, finding what is it that you can do, and finding who you can work with that can help you to put together something that is can make a meaningful contribution. So I don't have an easy answer for that. It is hard, but I think it's, like as you said before, being creative and figure out, well, I can't read this paper, and I can't do what they're talking about. We just don't have the facilities. We don't have we can't buy the samples that they need, whatever it might be. Well, maybe I can't work in that area, right? If you're in high energy physics, you can't do that unless you have some really big equipment. But what can you do? Or on the other side is there's computational work that's important. If that may not be, if you're an experimentalist, that may not be helpful, but that opens up some possibilities that there might be analysis or simulations or something that you can work with someone that doesn't have quite the same resources. So you might need to adjust what you do based on what the resources you have available.
Okay. Next question. Maybe from Mr. Diansah.
No, thank you, Prof. Nas. No questions.
Okay. I see here Professor Winaya maybe here, I think. And Ibu Sri Purnomo. Yeah. Please, if you have any question. Mr. Luby, I think, is also here. Okay. I think everybody is satisfied what Professor Jeff Fergus explained, and then I hope we can discuss later beside this webinar. And as Prof. Aryo said that Professor Jeffrey Fergus will be in our department in Mechanical Engineering, University of Indonesia, and will be accompanied by Pak Ardiansyah, as hello for him, so you can discuss later. So again, thank you very much, Professor Jeffrey Fergus, for your material today and then for discussion. And I hope for today and for the next webinar, we can continue with different topics. As he said, Professor Aryo, this is part of our, you can say, Department of Research in BKSTM. So maybe we're waiting for your contribution, or a member. Maybe you have some experts in your university, or you invite someone from abroad. You can ask us to arrange this webinar for the next meeting. So again, thank you very much, Jeff, for your presentation and for your meeting today. And I think we can close this meeting, and we can give applause for Professor Jeffrey Fergus.
Yeah, thank you.
Thank you. So maybe now it's a photo, photo session. It's very important, I think, for us. So Prof. Aryo will guide this photo, or who?
Bu Rita, silakan.
Bu Rita.
Ntar menunggu ini buka kamera semua ini.
Baik, terima kasih, Prof. Baik, Bapak Ibu, mohon yang bisa membuka kameranya bisa dibuka. Di sini ada 3 slide, akan ambil gambarnya. Di slide yang pertama, saya beri aba-aba 1, 2, 3. Kemudian yang di halaman kedua, 1, 2, 3. Halaman ketiga, 1, 2, 3. Baik, terima kasih.
Okay, see you. Bye. Thank you very much.
Thank you very much.
Thank you, Prof.
Terima kasih Bapak Ibu semuanya. Prof. Prof. Nasruddin, thank you very much.
Terima kasih
for your sharing. Bapak Ibu. Sampai ketemu besok ya, hari Kamis. Ada sharing assessment.
Thank you, Prof.
Kuliah.
Baik, Prof.
Terima kasih.
Terima kasih, Prof.
Terima kasih, Prof. Assalamualaikum.
Sama-sama, makasih Pak Akam. Sehat-sehat semuanya, Bapak Ibu.
Alhamdulillah. Assalamualaikum.
Waalaikumsalam.
Dulu Bang, linting kemana? Terakhir sudah ada.
Saya pamit dulu ya.
Kesempatan tadi baru diambil.
Oke, Assalamualaikum.
This one.